So basically, I think week 6 will be cover the combination circuit, mux, demux, encoder and decoder. Is it? Is it?
Yes.
Okay. So yes, I go through with the basics of the mux, demux, encoder and decoder. So what is the basically mux? Please explain week 6 practice assignment. Okay, so I will take that one, week 6 practice assignment, but initially before that one, I will go. So we start with the mux. What is the mux? Mux is nothing but the multiplexers. Okay, I take one example of the mux is that like I think you are familiar with the telephone lines. Okay, a single line will be coming. On the single line, the 8 connection will be distributed 1, 2, 3, 4, 5, 6, 7, 8. Okay, like that way. Similarly, if I go with the optical fiber communication, I think everyone have the internet connectivity. So if we have the optical fiber communication, okay, one optical fiber will be coming. After this one optical fiber, we basically distributed or we basically connect multiple users. Connect multiple users. Okay, so this is maybe the 8 users or maybe the 16 user or maybe the 32 user or maybe the 64 user as per our requirement, as per our bandwidth, as per our utilization. Okay, so all this work is done by the multiplexer. So how multiplexer do? Multiplexer will be take 8 different channels, okay, combine into the one part. Okay, so we required a mux multiplexers.
Sir, is it like inside the OS or is it like you're talking about the router?
Route, not a router basically. Yeah, we can say that it is a intermediate. Like if we have a router in our house, okay, before the router there is one device is available in your area. From there they basically split the connections, like 8 connections, 16 connections they can split. Okay, so that is the part of the multiplexers.
Like the box that they will keep
Ye-
to supply internet.
yeah, supply internet.
Okay, sir. Okay.
Okay, so now what they do, they basically combine as per our requirement either 8 cross 1 or 16 cross 1 or 32 cross 1 and 64 cross 1 combine into the one channel. Then at the receiver side what will be happen, they do the just reverse process. Okay, that is the demux. Again, demultiplexing, that means the signal that we combine as a single, now it will be separate into the multiple parts. Okay, so this is the mux or this is the demux. Again we go with the 8, 16, 32, 64. Okay, so 1 cross 8, 1 cross 6, 16, 1 cross 32, 1 cross 64, and little bit lower than this also, like for example we have a 2 cross 1 and 1 cross 2. Okay, that is also possible. Okay, so first, now we say that we are using a 8 particularly, we are using the 8 different user, we transmit the data of 8 user on a single particularly optical fiber, single medium, single wire is there. Okay, on particularly that wire I want to send the data of 8 user and 16 user. So what is the issue is that if I send all the data at the same time, so the all data will be clubbed. So a is this one data is this one data is this one, I am representing with other sign, one data is this one, I am representing with other sign, one data is this one. Okay, I am representing with other sign, one data is one. So like if we are saying that we are transmitting the data of 8 user on a single channel, so what the problem there arises is that all data will be clubbed, all data will be clubbed. Okay, so at the output we are getting the match mixed data and we can't retrieve original data. Okay, so what we do, we are using the mux systematically combine the data, but never mix, never mix. How it is possible it never mix? Basically, that particularly mux will be decided that which data will be go on as a output part. Okay, which data will be go as a output part. So for this one, we use some particularly select line. Select line. On the basis of select line position, the input data will be go to the output direction. The input data will be go to the output direction. Now, if I say that we have a capital N cross 1 is the mux. Okay, so how many select line is there? If 8 possible inputs are available, so 8 for the 8 possible inputs we required 3 different bits to create 8 combinations. So that means we require log 2 base n is the select line. Okay, is the select line. Is it clear? So if we design a n cross 1 mux, we required log 2 base 2 n is the select line. If we say we have a 2 inputs, okay, output is always 1. So 2 cross 1. Okay, how many select line is required? Log 2 of 2, capital N is 2. So that means only one select line is required. Now this is my select line. This is my select line. If select line is 0, the I0 bit is appear at the output. Okay, so if I say the select line is 0, output is nothing but I0. If I connect I0 as a 1, the 1 will be getting. If I connect I0 as a 0, the 0 will be getting. Okay, now if I select S is equal to 1, okay, so there is no effect of the I0, no effect of the I0. The I1 that we connected, either 0 or 1, that will be transmitted 0 and 1. Okay, so simply we say if I select S is 0, I output is the input I0, and if we select 1, input is 1. Now if I draw the, if I basically calculate the expression of this one, okay, so my output will be like, it is a I naught coming when S is 0, so S bar, and I1 is coming when S is 1, that means simple S. Okay, so my expression for the Y is I naught S bar plus I1 S. Now if I put the value of S is equal to 0, so this become 1, this becomes 0. It is 1, it is 0. So what is the output? Y is I naught. If S is equal to 1, so this becomes 0, this becomes 1. Okay, so we are getting Y is I1. Okay. Any doubts? Yes, any doubts?
Means that at different inputs you will get the different values of. Means I didn't understand that.
Different inputs, we are getting the different value. That means
Like for S0 we get I naught, and for S1 we get I1. So
yeah,
I was confused.
you are confusing. Like for example, we are using uh, like I say that your data will be connected at this point, okay, and your friend data will be connected on this point. Now you get both particularly data here. Okay, now if you transmit the both data at the same time, so what will be happen? Your data match with your friend data. Okay, and due to the mixer, you are getting the incorrect data. Okay, so now what you have
Yes,
to do, you are using one particularly selection. This is not an invert, so one particularly selection. Now on the basis of selection, you are getting a single data at a time, single data at a time. Okay,
okay,
now
okay. So
clear. So
means
either,
if there is a mixer, it gets messed up. So that's why
yeah, it's
we,
a max up. So we require the multiplexers.
yes, sir, got it.
Okay. So now the thing is that why we require the multiplexer? Why? Because if we have to install a system for a longer distance, we know that there are lots of wire are coming. Like if we in our locality, if I have a in locality 64 houses are there and everyone requires some connections. Okay. So what is the way that if this is the hub, if this is the hub, we require 64 wire for this locality. So it is very mesh up. Okay. It is very mesh up. Everywhere you see the wires. Everywhere you see the wire. Okay. So what should I do? I use the hub. With the hub, I use one mux that will combine 64 data at a one. So one wire will be go into the society of 64 houses. Clear? Is it clear?
Yes, sir.
Okay. Yes, any doubt? Now similar way, if I have a 4 cross 1 mux, so now the value of n is 4. So how many select line is required? 2. So we just select the S1 and S0 2 select line. Okay, so
Sir,
there is
where will the mux be? Like, will the mux receive 64 wires directly, and
where the, yeah, I am not understanding your
like
question.
the mux will receive 64 wires directly from hubs?
Yeah, but we can install this mux on in a hub now. So there is no wire you can see in the environment.
Yeah,
It
okay,
is a
sir.
directly connections. Okay, like for the telephone exchange. Okay, if you go inside the telephone exchange, there are the lots of, because in the previous time, if you go any exchange like BSNL and anywhere, so you that there are lots of wire. If this wire coming in the outward outside direction, okay, if I create a particularly wires combination in a house, no issue. But these wires when they are coming outside, so it is a very huge.
Okay, sir.
Okay, so we use this connection 64 wires. We use this connection, but it is inside the room. Okay.
Yes, sir.
Now clear? Any doubt?
No, sir.
Okay. Now if we go with the 4 cross 1 mux, so we required a 4 lines. I0, I1, I2, I3. We required 2 select line. One is the S1, second is the S0. Okay. The journal notation we are using is that if we take 2 select line, so the select line that is shown is here is the MSB, the select line that is shown here is the LSB. Okay, that is the journal notations. Every books if you go, so you just see that it is a MSB and this is the LSB. Now it is the output Y. Now if select line 0 0, so what is the Y? Y is I0. If it is a 0 1, I1. If it is a 1 0, I2. And if it is a 1 1, I3. Okay. So now if we write down the equation, so for this one the equation is I0 multiplied by the S1 bar S0 bar. This one is the I1 multiplied by the S1 bar S0. This one is the I2 multiplied with S1 S0 bar, and I3 multiplied by the S1 and S0. So overall equation of Y is what? I0 S1 S0 bar plus I1 S1 bar S0 plus I2 S1 S0 bar plus I3 S1 S0. So this is the complete equation. Now if you check, you put any value of S0 and S1, only one select line will be connected as the output. Okay.
Yes, sir.
Now in a similar concept, we have a demux. Can I explain 8 cross 1 and more? Okay, the concept is same. If I take the 8 cross 1, so we have a 3 select line S2, S1, S0 and Y. So if all are 0, we are selecting the I0, and similar way, if all are 1, we are getting a I7. Okay, now we can write the equation S2 bar, S1 bar, S0 bar, I0, and for this one S2, S1, S0, I7. In this way we can, okay, write more equations. Now finally, what is the Y? Overall Y is the combination of all, particularly from Y0 to Y7. Okay. Now similarly, if we are talking about the demux, so demux, as I already told, it is 1 cross n. Okay, so now one line that is coming from the backside where all data will be mux. Now we have to convert again into the multiple lines, so that every data will be go to the different users. Okay, again the concept of the select line is, select line S is nothing but log 2 base of n. Okay, so if I am talking about the 1 cross 2, so it is a 1 input line, that is I, and 2 output line, that is the Y0 and Y1. On the basis of this one, we are taking the select line. Okay, so what is the equation for Y0? If S is 0, okay, if S is 0, I, that is input, will be connected to the Y0. So if S is 0, Y0 is equal to I, and if S is equal to 1, Y0, Y1 is equal to I. Okay, so if I draw the truth line S, Y1, Y0. If S is 0, Y1 is 0, Y0 is 1. If S is 1, Y1 is 1, Y0 is 0. Okay,
Sir,
yeah,
you taken one input line, right?
yeah,
And one selection line also.
yeah.
Then, sir, according to this formula, log 1 equal to 0, sir. Then selection line should be
I
0.
am, this is
Log.
the, now this is the n. This is the n. This is 1. Okay, the formula is log 2
Okay, sir.
base log 2 n. Now our n is changed. Initially it is a 4 cross 1. The output is always 1. This is n variable. Okay. Now in the DK, in the
Yes.
demultiplexer, it is a 1 cross 4. So input is 1, output is changed. It is a 2, it is a 4, it is 8. 16, 32
Okay, sir.
I have. Okay. So that's why. Any other doubts?
Sir, could you please explain the demultiplexer again, sir? I didn't get that. How
Okay.
that they select the selection line. Because
Okay.
in multiplexer, we have given that input and they select output from the selection line.
Now, for example, is that we are taking one case. Okay. Now we have a 4 user. The one way is what? Okay. They user 1 and user. Basically, that is a source. I just take one example. That is the source and that is the destination. Okay. The distance between source and destination is 100 kilometer. Okay. Now, if user 1 want to transmit the data from the source to the user 1 at the destination, and user 2 want to transmit the data to the user 2. What is the problem in that case? We required 2 wires of 100 kilometer. Okay. So, cost is increased. Then if 2 wires will be going to the 100 kilometer, maybe we require the more maintenance. Okay, like for example, all 2 wires will be broken down. So what should we do? We have to change two wires. Okay, so cost is increased, maintenance will be increased. Okay, and third is that it is a not a complex, but we can say it is a like somehow is that if 100 wires will be transmitting, so we have to check that if like for example 100 wires. Okay, and due to the wind there will be the cross junction, and if there is some issue in the wire, in the any of the wire, so what we do, we have to analyze from the 100 kilometer that which wire will be break down. Okay, which is the wire of that one, which user is not transmitting the data, because all it is possible that all 100 wires will be clubbed with each other. Okay, the second approach is that we are transmitting the data with one wire only, so we are not required two wires, we require the transmit the data with the one wire. So we use one multiplexer here, club the data of user 1 and user 2. Okay, from one wire I can transmit at the destination, again the user 1 and user 2. Okay, so the thing is that only one wire is required. Clear? Any doubt?
No, sir.
Sir, one question.
Yeah.
Sir, when we are when we are muxing,
Mhm.
when we are multiplexing, we are sending a signal down the single wire,
Mhm.
right? Now, when at the destination at the demuxer, how will the
Mhm.
destination know that uh, are we shorting the select lines from multiplexer to the demultiplexer
That
also?
basically is a part of when we transmit any the data. Okay, on a wire or basically any medium, we transmit some encoded and decoded bit with them.
Okay.
Okay,
Okay.
so on the basis of that one, we can define that which user data is this one. According to this one, we select the select line.
Okay. So there is some
Yeah, that
predetermined format.
pre-processing and post-processing is the different thing. That is not a part of this one. That is a part of a computer. If we are transmitting the data in a long data, so first thing is that we can convert into the packet. After that, we use some particularly prephases. We can use some particularly header files. We transmit that one, and at the receiver, we can club the data.
Okay.
Okay, that is a different part. But we can, when we transmit the data, like for example with select line, like what is the value of select line? Select line is 0. So here it should be clear that select line should be 0, then u1 data will be transmitted to the u1.
Right.
if it is a s is equal to 1 at this side, so you transmit the data u1 for u1. Okay, you transmit the data for u1, but it will be received at u2. Okay, but that is a processing part. We include header files with them, so it will be easily analyze that which data will be transmitted and for which receiver it will be transmitted.
Okay.
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 But the thing is that if we receive the data by one particularly part, we have to distribute this data on the u1 and u2 on the basis of select line. Okay, so this is a mux and this is a demux.
Okay. Okay. Sir. Thank you.
Okay, now clear who are not getting the demux? One student who is saying that not getting the demux. Now it is clear.
Yes, sir.
Okay. Okay, that is the demux. If we have a 1 cross 4, so that is the I, y0, y1, y2, y3. Okay, for this one we require two select line. So we require a two select line. One is S1 and second is S0. On the basis of select line, we get that this particular input line will be connected to what. Either it will be this one, either this one is this one, and this one. I think in the ESTCA and EEC, you just remember that one particularly part is this one. Okay, this is the switch. Okay, this switch is connected to this part or the switch is connected to this part. Okay, so we can move the switch. Either the switch will be connected to this one or either the switch will be connected to this one. So the data that is coming, either it will be go in this direction or it will go in this direction. So basically it is a switch. So if we are talking about the mux is nothing but a switch, mux and demux, but it is a digital switch. It is a digital switch. Okay. Any doubts?
Sir, now mux is like common for the whole society. Where will demux be? That will be inside, like that is inside the
If,
router.
we are talking about the like broadband connection you already have. Okay, so like this is the basically hub. Okay, with the hub there is a mux. Okay, with the mux we are using a single. Again we are a one more mux. We are a one more mux. Okay, now we required one mux. Okay, so if we like for example we have a three society that is nearby, so we are using the 64 cross 1 mark, 64 cross 1 mark, 64 cross 1 marks. Okay, and we use the 4 cross 1 marks. Okay, now from this one the data will be transmitted on a single wire. Now when it comes into the your society, there is a one demux. Initially it is a 1 cross 4. It will be convert the signal into the third part. Fourth part is completely blank, grounded, because we are not connected to the 4. 1 2 3 is connected, fourth is the grounded. 3 is connected, 4 is the grounded. Okay, now with this again we are using the demux. Okay, so with this is the input line, we are getting the 64 connection. Okay, now these connection go to the user, like you are the user, so the broadband connectivity go in this way.
Sir, so
It
the
will be
broadband boxes in like the houses or in societies are actually demuxers, not box.
demux. Yeah, demux.
Okay, sir.
Okay, muxing is already done, where the line will be start, where basically they create a server. Okay, the muxing will be start from there.
Okay, sir.
Any doubt? Okay, so this is the mux and demux. Now if we are saying that we can use this mux for the other combination circuit or live pod, okay, like we are using we are not having a 4x1 mux, okay, and we implement this particularly with the help of 2x1. Okay, so we can do that one also. How we implement this one? So we have a 2x1 mux, and so we have a 2 input line for one, 2 input line is 1. So how many input line is required? 4 input line. So now if 4 input line is available, so we can say it is a 4. 1 output line, that means it is a 4x1. Clear?
Yes, sir.
Okay. Now this is the output line. Again, we are using this as a input for this one. We are using this as a input for this one. So now 4x1 is complete. Now we are talking about the select line. Okay. Now for the 2x1, how many select line is required? 1. For the 4x1, we are required the 2 select line. Okay. We can take that this particularly select line is common. So one select line is this one. I will take two particularly cases, is that if this select line is S0 and second if this select line is S1. So one select line I am using for both, that is a common, and second select line I am using for this particularly. Okay, so if this one is S0, we are taking this one is the S1. If this one is the S1, we are taking it is the S0. Clear? How I naught, I1, I2, I3. So initially what we consider that we are taking this one as S1, because I already told you that MSB, in the MSB we are using the S1, in the LSB we are using the S0. So on the basis of that one, I can take this one. Clear? Now,
Yes, sir.
if I am considering this is the Y1, so what is the value of Y1? Or I can say that S1, S0 and output Y. If both are 0, 0, 0, 1, 1, 1, 1, 0, sorry, 1, 0 and 1, 1. Okay. Now if S1 and S0 both are 0, so if this is 0, so what will select from here? I0. And what we select from here? I2. Clear? How? If 0, so first input will be connected as output. If 1, second input will be connected as output. So if S1 is 0, we are taking Y1, this is the Y1 and this is the Y2. Y1 is I0, because when it is a 0, first line will be connected with the output. This one is 0, so when first line will be connected with the output. So Y1 is I0 and Y2 is I2. Now when S0 is also 0, so we are getting Y1 as a Y. So Y is nothing but Y1. Yes, any doubt? Any doubt?
No.
Okay, and that particularly Y is Y1, so Y1 is I0, so I can say it is a I0. Clear?
Yes.
Now when S1 is 0, again the S1 is 0, so Y1 is I0 and Y2 is I2. Now S0 is 1, this is 1. So when S is 1, Y is Y2. Y is Y2 and Y2 is what? I2. Okay, so when 0, 1, output y is nothing when I2. But exactly when we go with the 4 cross 1 marks, this is the 4 cross 1 marks. So when 0 1 I1 should be the output, but we are getting I2 as a output. So that means there is a mistake. Okay, there is a mistake. Now I go clean this one. Consider that this is the S0 and this is the S1. Now again S0 is 0. So we are getting I1 as I0 and Y2 is I2. Y is I0. Why? Because S1 is also 0 and that is I0. Y is nothing but Y1 and that is I0. Now when S is 1, so if S is 1, what will be getting? We are getting I1 here and I3 here. Okay. Now S1 is 0. If S1 is, so we are getting I1 and I3. Now when S1 is 0, so S1 is 0, we are getting Y1 as a output. And what is the Y1? Is the I1. Okay. When it becomes 1 0, well, again S is 0, so S is 0, we are getting I0 and I2. Okay. And when S is 1, S1 is 1, so we are getting Y2 as a output. And what is Y2? I2. Okay. And when both are 1, so we are getting I1 and I3. And what is output? Y? Y is Y2. What is the Y2? That is the I3. Now we are getting the current sequence 0 0 I0, 0 1 I1, 1 0 I2 and 1 1 I3. Okay. So that means this select line sequence is correct. So when we are designing a basically single mux, our sequence of the select line is from the MSB to LSB, move from the right to left. This is the MSB and this is the LSB. Okay. Now if we are creating a hierarchical structure is that we are implementing a higher order mux with the help of lower order mux. Our sequence is like from LSB to MSB. Clear? Any doubt? Now we are implementing a 8 cross 1 using 2 cross 1. Okay, so we required a 8 select line and we already have a 8 input line. We have a device that has only 2 input line. So how many mux is required? 2 cross 1 mux is required in the initial stage. 2, 2, 4 line, 2, 6 line, and 2, 8 line. Now 8 input line is completed. In the output part, we required a 1 line. So 1 is we are getting. Okay. Now from here, 1 output is coming, from here second output is coming, from here third output is coming, and from here fourth output is coming. Again we have a 2 cross 1 device, that means we want to combine that one. So we required again a 2 cross 1. We required again a 2 cross 1. Now we are getting 1 and 1 2 output, and in the final stage we required only 2 input. So can I combine these two? Okay. Now 2 cross 1 mux. How many select line is there? 1. And for 8 cross 1, how many select line we required? 3. So can we see that 3 stages are there? So if I combine all particularly select line and say it is a S naught. Why it is S naught? We already explained. When we are creating a hierarchical structure or when we are creating this cascade structure, always we go from the right to left as a LSB to MSB. So S0 is the LSB. Now for when I combine these two, so it becomes a S1, and if I combine this one, so it is S2. 2 cross 1, 2 cross 1, and 2 cross 1. So if we implement 2 cross 1, sorry, 8 cross 1 using 2 cross 1, we require a 7 marks. Any doubts?
Sir, in the case of selecting the lines, we go from LSB to MSB. And
Hmm?
what you said, like you said, sir, for selecting the lines, we go
Hmm?
from LSB to MSB, no?
Yeah.
And for the other condition that you said that goes from MSB to LSB, what was
Yeah,
that?
if we required a 4 cross 1, so in that can we go the MSB to LSB from right to left.
Okay, okay. So when we
And
do directly, okay,
yeah,
yeah, got it.
if we create a 8 cross 1 as a single, so we required a S2, S1, S0, right to left, LSB to MSB to LSB. But here, if we go with right to left, we required a LSB to MSB. Here MSB to LSB. Okay,
Yes, sir.
clear? Yeah. Now, the second advantage of this mux is that we can create a gate also. Okay, or we can use OR gate to create a mean term, or basically the mean term and max term. Okay, now if we have a 2 cross 1, and that is I naught, I1, S. Okay, if I want to create a NOT gate, that means only A input is there and we are getting output as a bar. Okay, so in place of S, can I use a? So what is the question here is Y is A bar I naught plus A I1. Okay, now if I give the A is 0, so at A is 0, so this becomes 1, so we are getting Y naught, and if A is 1, we are getting Y is I1. Okay, so if A is 1, what we required? We required as a 0 as a output. If I naught is 0, so Y is 0. And if A is 0, we are getting Y is I naught. If I naught is 1, Y is 1. Okay, So we can create a NOT gate using a 2 cross 1. Any doubt, or should I explain it?
Sir, can we take this gate is this multiplexer is also AND gate or gate? Because in both gate, if we provide both one input, both input are same, then we are getting invert of it. And here it is also we are providing one input and we are getting invert of it.
Yeah. So here we are getting the inverter. So any doubt in the inverter? Yes. Any doubt in the inverter? No doubt. Any doubt in the inverter part? How we design this inverter using the 2 cross 1 mux? Shall we move forward? Student, please
Yes, sir.
speak. Shall we? Okay. Now the thing is that we have to create a XOR gate. So this is my input, this is my select line. This is the I naught, I1, S. So what is the Y? I naught S bar plus I1 S. Clear? Now what is the expression of XOR gate? If I'm taking I naught and S is the basically select line, select or input line. So if I design a XOR gate, so the equation is I naught S bar plus I naught bar S. Is it clear? This is the
Yeah.
expression of XOR gate. If I naught and S is the input, so this is the expression of XOR gate. And what we are getting from the 2 cross 1 mux? It is a I naught S bar plus I1 S. So when I compare these two equations, I can say that if I select I1 as a I naught bar, I1 as a I naught bar, so we required a one NOT gate. So I1 as a I naught bar. So what is my equation? That is the I naught is selected when S is 0, so S bar, plus I naught bar is selected when S is 1, and that is nothing but I naught X or S. So this is the expression of XOR gate. This is the expression of XOR gate. Now the thing is that in the, if it is mentioned that we don't have any gate, we have to implement this XOR gate using only the 2 cross 1 mux. So we required one inverted.
So we need one more mux.
One more mux. We have already inverted particularly this using this one. So if I, in the place of inverter, I use 1 cross 1 2 cross 1 mux. Okay, one more 2 cross 1. In the place of inverter, I use 2 cross 1 mux. Okay, so 1 and 1. So 2 cross 1 mux is used to implement the XOR gate. Okay.
Yeah.
If I want to implement some more functions, so we can implement that one also. Like we have to implement the XNOR gate. So if this is a 2 cross 1 mux, I naught, I1 S, so Y is I naught S bar plus I1 S. Okay, now what should I do? If I use the I naught and S is the input of X NOR gate. So what is the equation?
I not bar S bar.
I naught S plus I naught S bar.
Okay, I naught bar S bar plus I naught S.
Right.
Okay, so this is the I1S in place of if I put as a I1. So it is a I1 bar S plus I1S. Okay, I1S we already get. What we required? This is the I1 bar S bar. S bar we already required. So if I replace this I naught with the NOT gate, if I say that this I naught is nothing but I1 bar, so the equation should be I1 bar S bar plus I1S. That is the X NOR gate.
Right.
Okay, so we
Yeah.
can create a particularly gate also. Now if I want to create a sigma m 0 2 3, okay, now we say that two input is required, y is a y ab is equal to sigma m 2 3. We have a 1 2 cross 1. One is the select line, two is the input line. Okay, so S is 0, I naught is selected, S is 1, I1 is selected. Okay, should I break into a two part? If I take a I naught and S, okay, so if I am taking two inputs, so when both are 0 0, it becomes 0. When both are 0 1, it becomes 1. When both are 1 0, it becomes 2. And when both are 1 1, it becomes 3. Okay, now which mean term is defined? 0 2 and 3. 0 2 and 3 are defined. Okay, if these two terms in a column part, so if both term will be available, this is the S is equal to 0, or we can say the it is a is equal to 0, A is equal to 1. Yeah, this is the B is equal to 0, B is equal to 1. Okay, if I say that 0 2, okay, 0 and 2, so if this I am talking about 0 and 2, so we can say the value of B is always a constant. So can I represent as a B bar? Why? Because A value is variable. 0 and 2 is a create a group. When I create a group of 0 and 2, so the value of A is initially for this one is 0 and value of A is for this one is 1. So the value of A is changes. Okay, value of A is changes. Now if we are talking about in the case of multiplexers, so which variable, which particularly value will be changed? Only the select line value will be changed. Input line is not changed. If I select if I connect a input as a 0, okay, so we have to change this particularly input by changing complete circuit. But the select line is possible that it will be sometimes as a 0 and sometimes as a 1. So only the option to select this complete circuit operation is dependent on the select line value. So it is possible that select line value will be changed. Okay, and input will be always constant. Input will be always constant. So when I create a zero grouping of this one, so A is 0, B is 0, it is available in the mean term. A is 1, B is 0, it is available in the mean term, and A is 1, B is 1, it is available in the mean term. So for this particular scenario, my input B is constant and the value of B is the B bar. Okay. Now for this one, if I am talking, A is 1, that means if select line is 1, this particularly point will be select. Okay, so if I connect as a B here, sorry, if wait a minute, what I do here is okay, don't be confused with this one. What we do, we write the expression. So it is a bar, B bar plus A bar, A B bar plus AB. Okay, when I take as a common of these two, from these two, what should be taken common? B bar is a common, so it becomes A plus A bar. Okay, so B bar plus AB. Is it clear?
Yes, sir.
Okay, if I multiply B bar with 1, there is any issue in that? I think no. Okay, I think there is no issue. Now, if I connect B here, okay, so when B value will be selected, this particular term will be go as a output. So can I connect as a 1 because it becomes a B bar. In the case of B bar, 1 will be goes as the output. Okay, and when the B is 1, so it becomes a B, and in the case of B, A will be multiplied with that and it will go at the output. A will be multiplied with that and will go with the output. Okay, so we can design a 0 sorry, sigma M023 with this particular circuit. Okay, if other way is that, like I am taking the A bar, B bar plus, if I take a common from this one, if I take a common from this one, so the common part is what? A is the common, remaining is B plus B bar. Okay, so that is the A bar, B bar plus A. So which input is changed? First of all, in this scenario, what is the output equation? Is the output equation Y is when B is 0, 1 is, so it is a B bar. When B is 1, it is A. Okay. Now in the second scenario, what we do, we are common from the last two terms. So again, we design a 2 cross 1 mux, 2 cross 1 mux, one select line. Now if you see that initially A is A bar and now the A is 1. So there are two terms is available where A is A bar and A is 1. So if I say connect A is here, so when A is 0, so this become A bar. Okay, now if A bar, which select line is selected? I naught as a output. So what is the value of I naught? This B bar. So we are getting A bar, B bar. Okay, when A is 1, that means it becomes A. It becomes A. Now if it is becomes A, it multiply with 1. So what is the value of I1? Is 1. So we design particularly this mean term expression using a 2 cross 1 either this way or this way. We can take some more complex, so I think you will much familiar with that. FAB is equal to sigma m01, it is given. So can I write it as a bar b bar plus a b bar?
Yeah.
Okay, so I think I just designed with two ways. There are two ways. Okay, first of all, I designed that if I'm taking 2 cross 1 mux. So first of all, we have to select that which particularly point will be connected with the S select line. So if you see in the expression the value of a bar and a, so that means variable a value is changed. Variable a value is changed. One time it is a bar and second time it is a. So can I connect this select line at this point? A. Now what is the possible values for a? This select line, either this is the 0 or this will be the n. If it is a 0, so we can consider that a bar. If it is a 1, we can consider as a. If a bar is a select line, what is the input passes through the output is b bar.
Sir,
So
it will be A bar, B bar plus A bar B, no?
0 1
Expression.
na? Yeah, sorry, sorry.
Yeah.
That is a bar b. Now we change that one. Okay. So which particularly where select line will be changed? B bar is changed. So we can connect B here. Now the value possible value is B is 0 and B is 1. If B is 0, so it consider the B bar. If B is 1, so we consider that as a B. Okay. Now when B bar is passing, when B bar is selected from the select line, we require this input that will be getting as a output. Okay. So when B is 0, B bar is selected. B bar is already there. Now when B is 0, I naught is selected. If I naught is selected, so the A bar will be considered here. So when B is 0, so becomes B bar and multiply with the input is the equation. Second is when B is 1, this one. Okay, when B is 1. So I1 is what? Again, it is a bar. So when B is 1, I1 is passed at the output. So when B is 1, I1 is passed as the output and that I1 is a bar. Okay, this is the one way. Second way is that if I take a common a bar, so it is a b bar plus b, so that becomes a bar. Okay. Now again for this one we have a multiple solution 2 cross 1 y select line I naught I1. What if I select S is 0? Okay, so which one is selected? I naught is selected. So can I connect directly I1 I naught here? So when S is 0, I naught is passed. So our output equation is a bar. When S is 1, I1 is selected, but there is no other term. So can I connect with the 0? So 0 is connected here and it will be added 0. So no equate. So it becomes a bar. Clear? Any doubt?
Sir, when you choose S equal to 0, then A bar goes out. Then
Yeah.
0 dot A bar, it's become 0, no, sir?
No, the equation is what? I naught S bar.
Yes,
So if
sir. And
S is 0, so S bar is 1. 1 multiplied by A bar is 1. A bar.
okay.
Okay. And when S is 1, I1S. So when S is 1, this one will be select. So when this one will be select, I0 will be go. So 0 multiplied by S1 becomes 0. So this system is 0. And when S is 0, so it becomes 1 multiplied by I naught is A bar. So it becomes A bar plus 0 becomes A bar. Got my point? Any doubt?
Yes, sir.
Okay. Now that there is second way is also available. If I connect a select line with the input, okay. Now when a is 0, a becomes 0, so that means it is a bar. Okay, what we required as the output? A bar. So if a is 0, so that means a bar, and a bar multiply with 1 is the a bar. Okay, when a is 1, it becomes a multiply with 0 becomes 0. So again it is a bar plus 0, and final answer is the a bar. Okay, so same mean term expression 0 and 1, we can implement this particularly mean term expression in 3 way using a 2x1 marks. Any doubts so far? Please tell me. Otherwise, we will stop here.
So
Sir,
can
I
you
have
repeat
some
it?
regarding some previous topics,
Repeat regarding some previous topic means
like the minimum number of gates.
questions.
No, sir, not actually questions, but a doubt.
Okay.
Like
Yes, tell me.
if a question is given that there is any function,
Mhm.
Boolean function, and there are three variables A, B, C, and function can be anything. Should I first take the simplification of that SOP
Yeah.
and then calculate the minimum number of gates, or should I
SOP.
not take the SOP and then
First
calculate?
take the SOP, minimize them. Okay. First thing is that.
Okay, so
Then
I need
second,
to first minimize the SOP.
yeah, minimize the SOP.
By minimize, you mean
Like for example, we have a ABC plus A bar BC. Okay, and we have only two input gates are available. So what should we do? First we AB one gate, then this one. So two gate for this one. Okay. Then A
okay.
bar one gate, then A bar B one gate, and then output will be the multiply ending with the C. So we required a three gate for this one. And for the O-ring of these two, we require one gate. So 2 plus 3 plus 1 total, how many gates is required? 6.
But sir, we can take BC common, and then it will be BC into A plus A bar.
Yeah, yeah.
Then this will be
So I
only
say
BC.
that, so if I can take a BC as a common, so it become A plus A bar is 1, so it is a BC. For the BC, we required only one gate.
Okay, so I need to simplify first.
Yeah, so you have to minimize them first.
But like I need to implement the function with NAND only or NOR only.
Okay,
Then
no issue, no issue. Any particularly Boolean expression with any gates, first thing is that you can simplify that.
okay. So I need
Then,
to first simplify and then check NAND gates
yeah,
and NOR
then check
gates.
NAND gate.
Well, like in this example, to implement BC is like a AND gate. So I need to
Yeah.
implement the AND gate with NAND or NOR gates, right?
So yeah. So you have to take the one NAND gate. So it is a B and C. What is the BC bar? Again, I convert this one. So we are getting a BC bar and bar that becomes equal to the BC. So two gates is required.
But in the lectures, professor didn't do this. He only took the SOP and used the NAND and NOR gates.
So that they are not telling about the minimum number, no? I think if
Okay.
there is a not a consideration that we have to require, we ask that how many minimum number of gate. Like for example, if I simply implement this one with the help of NAND gate, okay, how many gates? Maybe possible 6 gate, maybe possible 8 gate, maybe possible 9 gate. Okay, we are not giving any constraint that we require the minimum number of NAND gate. We only ask that how we implement using NAND gate.
Okay.
Okay, so
But
there
sir,
is
it can
no
also
such.
happen like if I use a 3-input NAND gate and 3-input NOR gates,
Yeah.
and without simplification, if I only do the SOP form, then the number of required NAND and NOR gates may come lesser than if I simplify it and then use NAND and
if
NOR
if
gates.
if it is a 3 implement and we have a equation with the three inputs, either a bar, b bar, c bar, or a b c, any value. Okay, so there is no need of to minimize that one. Okay, if 3 input NAND gate is available, like for
Okay.
example,
So if 3-input NAND and NOR gates are available, then I can take the SOP in itself without simplifying it, right?
yeah, without simplification for that one.
Okay, okay. Thank you, sir.
Yeah. Any other doubts?
So, so the previous in this lecture,
Mhm.
I didn't got the two ways that you explained to uh what multiplexer thing. Uh,
You are not getting what?
uh, that topic only that you explained that how to uh, no. It's
Uh,
basically the Boolean expression that you take. Sir, can you go to the previous slide?
yeah.
Yeah. Not this. Little bit down. I didn't got the way to solve it, or you can say to make that inverter or a- anything.
Okay.
Down in down.
You are asking this one.
Yeah.
How we implement the inverter?
Yeah. Yeah.
The thing is that first of all, we remember that, like for example, we have a 2 cross 1 marks. Okay, I naught, I1. The first thing is that I remember every time that what is the equation of y. Y is I naught s bar plus I1s. Okay, now second thing is, if I want to use this particularly as a part of inverter, so y is, if I use the a, so it become a bar. Okay,
Yes, sir.
can I compare this equation with this one? Bar term is available, bar term is available. It will be multiply with 1, so that means I naught is 1. Okay, this
Yes,
term
sir.
is 0. This is the 0 time s. Okay,
Yes, sir.
we can say, so I1 will be connected with 0, I0 will be connected with 1, simple, and here we connect the a.
Okay. Okay. So first, you have to simplify that Boolean expression, or you can just apply it.
First, the better thing is that you can write a equation for the marks, output equation for the marks, and then secondly, which gate you want to create, just compare them, these two. That is the better way.
Okay. Means we have to write this expression that you have said,
Yeah.
and then we have to compare that with that Boolean expression.
Yeah.
Okay.
Like for example, if I want to create y is equal to I naught s bar plus I1 s, and I want to design a AND gate. Okay, so that is the I naught, or basically I1 s, I naught or I1 time s, or we can say the AB. Okay, now here you see that the bar term is available. Here you see that there is no bar term is available. Okay,
Yes, sir.
so if I connect A here, directly I connect B here. So AB, when A is 1, B is pass. Okay, when A is 0, this term is pass, and there is no particularly addition term. This term is 0. So what should I do? I just add this one. Okay, the bar term is 0 na, bar term, there is no bar term, so bar term is 0, so this means I naught is 0, so I connect I naught with the 0.
Yeah, I got it, sir. I
One
got
way, one way is this one. Second is that if I connect, this is the B, So B is connected with A and B bar. No bar term is there, so it is connected with 0. Second way. Okay. Or
Yes, sir.
if I say that it is a I just write as a B bar and bar. That is AB. Yes, that is AB.
Yes, it's a AB whole bar and then again whole bar.
No, 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 no. A only B bar and B bar.
Okay, okay, okay.
Okay, so 2 times B bar is simply AB.
Yeah, yes, sir.
Okay. Now if I connect here, so S bar. So when S is, so if I connect S is the B bar. Okay. We connect A. Why? Because if I compare this one, so S nothing but B bar and I naught becomes A. So we are getting a AB. So we connect S as a B bar and I naught as A. Okay. Second term is not available, so we connect as a 0. Clear?
Yes, sir. Got it.
If I connect
Sir,
if I convert into the A bar and bar multiply by B. Now if I compare, so what is the value of S? S is nothing but A bar. Okay. So what I do, I just connect S is A bar. Okay. What is the I naught? I naught is B. So I connect B here. Second term is not available, 0. So I connect 0 here.
Yes,
sir,
sir. Got
when
it.
you uh,
First,
sir, when
wait a
you
minute, wait a minute, wait a minute, wait a minute. Yes. Now clear how we design?
Yes, I got it.
Okay. Now the second question. Who is saying?
sir, when you passed A bar with B, then A bar becomes A bar is a 0, sir. Then A bar dot B becomes 0, na?
If I provide the A bar here, so what is the equation says?
A bar means 0, sir.
Okay, A bar is 0. I am not saying what is the value of A bar. I just say that this is the A bar. Possible that A value will be 0, possible that A value will be 1. It is a
Sir, we are
input. It is an input.
sir, we are
It is an
sir,
input.
we are writing equation in SOP
Okay.
form. Then
Okay.
bar represent 0, na?
Okay. So by represented 0. Okay.
Then 0 dot
Now,
B
now,
becomes 0.
now, can you write the equation? It is I naught S bar plus I1S 0 and again bar of this one. Why you forget this
Sir,
bar? Why you forget this
sir,
bar? This is the value of S, not a S bar. S is A bar. Now what is the value of S bar? S bar is A.
sir, we are writing equation in SOP form. Then
Any
bar
any form,
represent
any form we writing either POS or SOP doesn't matter. We provide select line as a bar. Okay. Now here only always the select line bar is available. Select line is A bar. What is the select line bar? Is A.
means if we are giving A and it become A bar, then it means we are putting inverter before that selection line.
Yeah, before select line we are putting the inverter because we are
Then
selecting, we are giving the S. Now if S is A bar, so that means it is not a S bar, it is a S. It is always
then
a
we have
S.
to use one more multiplexer there, na sir? Because for inverting that, we have to use one more
That is a
multiplexer.
different thing. I am not saying that only A and B input. If I say that only A and B input are available, we are using the one more inverter. Okay. I am not giving that which inputs are available, either A, B, A bar, B bar, both are available. I just design A and gate. That is the only thing. Clear?
Okay, sir.
Okay. If we are saying that A and B both are only the input are available. So what is the way we design this one is as this is the A, this is the B, this is the 0. We required only one. Okay.
Yes, sir.
Okay. We required 1, 2 cross 1 to implement a AND gate.
Yes, sir. Yes, sir.
Yeah.
Because I created this gate and you created A0 as a, then I think
I just saw that there are the different ways. If we are not defining a exactly the correct statement in the question, we can't say that only A and B input are available. There are three ways I decide to explain that we can create a AND gate with the three ways using 2x1 mux. That is only. Okay, we can create with this way. We can create with the some input as an inverter, either A bar or either B bar. Okay, if I mention in the question that only A and B input is available, then I can use this circuit and identify that only one 2x1 mux is sufficient. Okay,
Okay, sir, got it.
I just take one example that you go from one place to your house. So is it possible there are the multiple ways are available?
Yes, sir.
You can choose any particularly path.
Yes, sir.
Till I am not explaining that your time to approach your house is minimum. You can take any path. Either you go, you come into after 1 hour, after 2 hour, after 3 hour. That is all up to you. But when I mention that you have to choose a path that is required a minimum time to approach to the house, then you select that there is only one way where we go, and that particularly from this way I can approach to my house in 20 minutes. Okay, but till now we are not defining any conditions. We can choose any particularly way. So I just tell
Yes,
you
sir.
that how many ways is possible to create a AND gate. If I explain that, if I asking the question in a way that we have to identify the minimum number of mux required to create a AND gate, so we can use this way. Okay.
Okay, sir.
Yeah. Any other doubts?
No, sir.
Okay. So I think we should stop here.
So similarly, we can do for XOR, XNOR, and OR gate
Yeah,
also, no?
similarly,
By this technique.
similarly. You can create a multiple ways to create a XOR, XNOR, and any gates. Okay. If I am asking the minimum number of gates, that is a different constraint.
Okay, sir.
The best way is that which particular thing you want to implement, just simplify that one, and what is the actual equation of the mux, either 2x1 mux or 4x1 mux. Write the equation, compare, then select that which is the select line, which is the input line.
Yes, sir. Got it.
So I think thank you all.
Thank you, sir.
Yeah.
Thank you.
Yeah, bye, sir.